Mathematics class. Okay, let me start the class. Everyone knows that the beginning of all the lessons in grade 11 starts from observed mathematics of grade 10. So you have to be familiar with all the terms and topics that you studied in grade 10 to start grade 11. Okay, here you start mathematics always from a function, and you have to be familiar with different types of functions and operations on the functions, domain, range, period, symmetricity, like that. Okay, now here we start today's class with function. Do you hear me? Malay Sunira song? Am I audible? Okay, now we start the class with function. Do you know what is a function? The function is the function is a relation, that is a special type of relation which maps every element or which
यति ढिलो
okay. Rakesh sir, Rakesh sir. Okay, let me continue. समझना पौडेल है रोज करो सही प्लीज समझना पौडेल शुभम anything to ask okay just a minute okay okay I have come now uh, let me continue this you know there are different types of functions case of if you have any queries please tell me or you write me in the message box or the chat box okay in this function there are different types of functions we say and by classifying them we have they are only one to one or many to one to one or one to one and many to one and the second one it is onto any integer. These are onto an integer. These are the two classifications of functions. There are only one to one or many to one functions or onto any. If the function is one to one, then that cannot be many to one. If the function is many to one, that cannot be one to one. Similarly, if a function is onto, that cannot be into. If the function is into, then that cannot be onto and so on. This is just a background. Now we come to the next part, domain and range of a function. You know, what is the domain and what is the range of a function? Domain and range of a function. If we say the function f from a to b, if we define a function f from state a to state b, then state a is called the domain of the function. It is domain. And state b is called codomain. State A is called domain of the function and state B is called the codomain. The state of the images or the elements of A under the function f is known as a range. The state of all the images or set of the images of the elements of state A under the function f is known as the is known as range, and that range is a subset of codomain. If we use mapping diagram to explain about this codomain, and range, then we get set A is the set with elements 1, 2, and 3, and set B the set with elements, let us say A, B, and C. If one maps with A, two maps with A, and three maps with B under the function f defined from set A to set B, then domain is the set of the elements 1, 2, and 3. So we say domain is the set of elements 1, 2, and 3. And codomain is the set of elements A, B, and C. Codomain is the set of elements A, B, and C. And range is the set of the images of the elements of set A in set B. It means range is the set of these two elements A and B. Range is the set of the elements A and B. And in this function, domain is the set of all the first elements. It means it is the set A. Codomain is the second set B, where the images lie. The set where the images lie is codomain, and the set of images is the range. So you have to be familiar with this. And the next one, we come to the next. Here, you have to be familiar with some algebraic functions. There are two types of functions. Say algebraic functions and transcendental functions. The functions which are formed by using the basic operations, that is, the operations like addition, subtraction, multiplication, division, and taking roots on the polynomials. These are algebraic functions. The functions which are formed by using the operations addition, subtraction, multiplication, division, and taking roots on polynomials are the algebraic functions. The functions which are not algebraic are called transcendental functions. So we classify them as algebraic and transcendental functions. Okay, algebraic, algebraic, and transcendental functions. The algebraic functions you are familiar with are identity function. Identity function. And the next one, you can say, next one is constant function. Third one is linear function. And the next one is quadratic function. Quadratic function. And next one is cubic function. And the last one we can say polynomial function and rational functions. Rational function. Here, to identify all these types of functions, we can say identity function. Under the identity function, the image of an element is itself under the function. If the function is an identity function, the image of an element is itself. त्यो कुनै element को image आफै मात्रै हुन्छ. The element has its image itself. That's why identity function मा हेर्यो भने in an identity function or identity function मा हेर्यो भने simply we get that the image of 1 is 1, image of 2 is 2, image of under root 3 is under root 3, and so on. And we can formulate this identity function as f of x is equal to x. The function defined by this formula f of x is equal to x is an identity function. Here under this function, the image of f of 1 is equal to 1 we get, f of 2 is equal to 2, f of 3 is equal to 3, f of a is equal to a, f of b is equal to b, like this. So this type of function is an identity function. And the next one is constant function. Under the constant function, the image of any element is constant. So we can define this function as the function defined by the formula f of x is equal to c for all x in for all x in the domain of the function f. Okay, let us say a. The function f defined from set A to set B defined by f of x is equal to c is a constant function. Okay, f of x is equal to c को form में defined गरेको छ भने that is a constant function. Let us find f of 1. f of 1 निकाल्यो भने कति आउँछ c. f of 2 is equal to c. f of 3 is equal to c. The image of any element is the constant c, so it is a constant function. The function f defined from set A to set B given by f of x is equal to mx plus c. It is mx plus c where m is non-zero, m is not equal to 0, it is a linear function. Similarly, the function in the form f of x is equal to f of x is equal to ax square plus bx plus c, where a is not equal to 0, this is a quadratic function. Similarly, the function f of x is equal to ax cube plus bx square plus cx plus d, where a is not equal to 0, is a cubic function. And here, simply polynomial function, all these functions are polynomial functions. That we have been using here, the algebraic functions, so just before all these are polynomial functions. So, to cover all the types of algebraic functions, we have taken here polynomial functions. F of x is equal to, let us say, a 0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3 plus an x to the power n. This is a polynomial function of degree n in our variable x. It is a polynomial function of degree n in x if this an is not equal to 0, where an is not equal to 0. Let us say an is non-zero. This type of functions are the polynomial functions. So we can say all these functions can be taken in the form of polynomial functions. Okay. And rational functions, rational expression, from rational expression we get rational function. Okay. Rational function, a function which are expressed in the form of f of x by g of x. The functions which are expressed in the form of f of x by g of x, where g of x is not equal to 0. G of x is non-zero. This type of functions are called rational functions if f of x and g of x are the polynomial functions. Okay, f of x and g of x are polynomial functions, then the functions in the form f of x by g of x where denominator, that is g of x, is not equal to 0 are called rational functions. Here The most important part is that you have to be familiar with the graphs of all the types of functions. Let me explain all this with the graph. Now for these algebraic functions, to draw the graph, here we start from the same identity function. Under the identity function, we get the image of an element is the element itself. Image of 1 is 1, image of 2 is 2, image of 3 is 3, image of 0 is 0, and so on. So here we get by drawing the graphs of the functions. If we draw the graph, we get the image of 1 is 1, image of 2 is 2, image of 3 is 3, and so on. Okay, you can see here in the graph, let us mark these axes as x-axis and y-axis. Mark the points 0, 0, 1, 1, 2, 2, 3, 3, and so on. You draw a line passing through these points. You can draw a line passing through these points. By drawing the line passing through these points, 0, 0, 1, 1, 2, 2, 3, 3, maybe on the root 3, on the root 3, and so on. We get the graph like this. It is the graph of an identity function. Here, the line is inclined with both the axes at the constant equally. It is inclined with the axis equally. It means the angle made by this line with x-axis is same as the angle made by this line with the y-axis. These two angles are equal. If this angle is taken as alpha, then this angle is also equal to alpha. So it passes from the midway between these two axes. It is the graph of an identity function. Simply by observing this graph, you have to say the type of function. Here, if the graph of a straight line is equally inclined to the axis, then it is the graph of an identity function. You have to identify by this word. Okay. And the second one, the graph of constant function. For the constant function, you have already got that f of x is equal to c form. That is, you can say constant function is constant function. You can take an example. Let us say f of x is equal to 3. For this function, the constant function f of x is equal to 3. It is a function, constant function f of x is equal to 3. Under this function, we prepare the table of values, say x and y. Okay. If we say the values of x and y is, let us take x is equal to 0, then y is always 3. It means the function y is equal to f of x is equal to 3. Then by substituting x is equal to 0, we get y is equal to 3. By substituting x is equal to 1, we get y is equal to 3. By substituting x is equal to 2, we get y is equal to 3, and so on. Let me draw the graph of these function. Okay. इसको ग्राफ ड्रॉ करो तो एरा को बस कौन सा. Okay, let me take the same axis. 0, 3, 1, 3, 2, 3. 0, 3, 0, 3. Mark this point 0, 3, 1, 3, 2, 3, and so on. Let us draw a line passing through these points. By drawing a straight line passing through these points, we get the graph is a straight line parallel to the x-axis. The graph is a straight line parallel to the x-axis. So the graph of a constant function is the straight line parallel to the x-axis. If we have to identify the function, by the help of graph. We always observe the line whether it is parallel to x-axis or not. If the graph of a function is a straight line parallel to the x-axis, it is the graph of a constant function. Okay? The next one, linear function that forms simply a line that is particularly we can say that it is also a straight line. It is the graph of a linear function as well we can say. But particularly we say it is the graph of constant function. It is the graph of we can say it is the graph of an identity function. Your graph of identity function, or it is the graph of a constant function. Similarly, for a linear function, you can take an example f of x is equal to x plus 3 like this. Okay. I'm checking your messages in the chat. Okay. 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 Let me check it. Okay. Hmm. मैले मेसेज हेरेँ यहीसँग रिलेटेड छ मैले पढाइसक्यो भनेर पनि लेखेको छ ओके I'm giving you the different approach of these types of functions. Okay, identity function, constant function. Constant function clearly it is the straight line parallel to the x-axis. For algebraic function, let's say for algebraic function we have other types of functions as well that we have already mentioned. Okay, and the next one is a linear function. Linear function. It is in the form f of x is equal to mx plus c. That is y is it is in the form y is equal to mx plus c. Let us say y is equal to 2x plus 3 or 2x minus 3 like this. Okay. From it we get a straight line. The graph is a straight line. Eh? That's what I mean. If graph is straight line and off. Let us make the table of values x and y. If we take x is equal to 0, y is equal to 3. If we take x is equal to 1, y is equal to 5. By taking x is equal to 2, y is equal to 7 and so on. Now plot these points 0, 3, let us say this point, okay, 1, 5, 2, 7 like this, okay. And this is the straight line. This is the straight line passing through the points 0, 3, 1, 5, 2, 7 and so on. You will get a straight line passing through these points, and simply we get the graph of a linear function is a straight line. Okay, graph of a linear function is a straight line. Here in this case the line is equally inclined to the axis. In this case also it may be equally inclined to the axis or maybe in other type of inclinations. Okay, and here simply you will understand that all these are also the linear functions in your level. I mean linear function so their graphs are also the straight lines. And the next one we can differentiate from linear function, that is a quadratic function. And to draw the graph of quadratic function, we get it is you are quite familiar with the graph of quadratic functions. You have studied completely or chapter related to quadratic function in graph. Okay, so its graph is a parabola that either opens upward or that opens downward. The graph of quadratic function is a parabola that either opens upward or opens downward like this. Okay, maybe the graph like this. Okay, it is the parabola that opens upward. It is the graph of a quadratic function. Okay, x y axis, and it is the graph of the quadratic function in the form y is equal to ax square plus bx plus c form where a is not equal to 0. It is the graph of a quadratic function. It is it either opens upward or opens downward. If A is positive, then the parabola opens upward, and if A is negative, then the parabola opens downward like this. Okay. If A is positive, then the graph of the parabola, that graph of the quadratic function, that is open upward parabola. If A is negative, then its graph is open downward parabola, we can say. And the next one is cubic function. To draw the graph of cubic function, we again take the set of values that satisfy the equation in the form y is equal to ax cube plus bx square plus cx plus d. And from that we get the graph like this. इसको हमको graph कौन सा है ना? Okay. If it is y is equal to x cube, then the graph is like this. It goes upward and the other part comes downward in the similar manner. It is the graph of y is equal to x cube. It is the graph of the cubic function y is equal to x cube. And if we draw the graph of another cubic functions, then we get the pattern is the same. Maybe starting from here, it is called the vertex. This point is called the vertex. This point is called the vertex, and we get the graph like this. Okay. Okay. The graph. Okay. Graph is like this naturally. It seems to be a tangent curve. Okay. It seems to be a tangent curve. Graph of cubic function seems to be a tangent curve. Okay. Okay. Now we come to the next. Here, to draw the graph of different types of functions. And to different types of functions को graph draw करने लगे, you can take the set of values that satisfy the equation. तो equation लाई satisfy करने के लिए you can take the set of values. So equation अब ये जाने तिनीहरूको set of values लेना, and from that you can draw the graph. Say rational function बने. Let me take the help of the example, an example to draw the graph of the rational function. Let us say the function is y is equal to f of x is equal to x square minus 4 by x minus 2, let us say. It will be a function okay, y is equal to f of x is equal to x square minus 4 by x minus 2. This is a function if x is not equal to 2. If x is equal to 2, this is not a function. Okay. If x is equal to 2, f of x is equal to x square minus 4 by x minus 2 will not be a function if x is equal to 2. If x is not equal to 2, then it is a function. You know that there is no image of 2 under the function f. If you find the image of the point, image of the element 2, then you will get f of 2 is equal to 2 square minus 4 by 2 minus 2 is equal to 0 by 0. 0 cannot be divided by 0. So it is not a function. If x is not equal to 2, then it becomes a function. To draw its graph, if x is not equal to 2, then we can simplify this function. F of x is equal to x square minus 4 by x minus 2 can be simplified as x plus 2 times x minus 2, and this divided by x minus 2. If x is not equal to 2, then x minus 2 is not equal to 0. If x is not equal to 2, then x minus 2 cannot be 0. X minus 2 is not equal to 0. Then non-zero factors can be cancelled on the numerator and denominator. And we get f of x is equal to x plus 2 means that is y is equal to x plus 2 is the function. And we draw its graph. To draw the graph of y is equal to x plus 2, we again prepare the table of values of x and y. Okay. Let us take the values of x and y as when x is equal to 0, y is equal to x is equal to 1 gives y is equal to 3 and x is equal to 2 gives y is equal to 4. You can plot these 4 points in graph to get its graph. But be sure that x is not equal to 2. X is not equal to 2. I'm writing here 2, but x is not equal to 2. Okay. X is not equal to 2. Let us not write x is equal to 2. X is not equal to 2. It is clearly given. So we don't write x is equal to 2. And let us say 3. When x is equal to 3, y is equal to 3 plus 2 is equal to 5. But here it is given that x is not equal to 2. If x is not equal to 2, then what cannot be the value of y? If x is not equal to 2, y cannot be equal to 2 plus 2, that is y cannot be equal to. If x is not equal to 2, then y cannot be 4. So there is no point 2 comma 4 on the straight line passing through these points. Okay. यसको ग्राफ ड्रा गर्नु पर्यो भने हामीलाई x को भ्यालु 2 होइन भन्यो भने y को भ्यालु पनि 4 होइन. त्यसो भए 2,4 भन्ने पोइन्ट यसको ग्राफमा पर्दैन भनेको. The point 2,4 doesn't lie on the graph of this polynomial function, that is a rational function. Okay. Let me draw the graph of this function. X is y axis 0, 2. It passes through 0, 2. You 0, 2, 1, 3, 1, 3. Let us say 1, 3. There is no point 2, 4. 2, 4 हेर्दा 2, 4 यहाँ पोइन्ट आउँछ नि, यो पोइन्ट होइन भनेको. There is no point 2, 4 in its graph. And the next one is 3, 5. 3, 5. This is the point 3, 5. Okay. Now we draw the straight line passing through these points, but the graph doesn't pass through this point. It means there is a break in the graph of the function at this point. यो पोइन्टमा ब्रेक हुन्छ हेर त, यहाँ एउटा लाइन आयो, it is a line towards this. अब फेरि यता पनि लाइन हुन्छ, a line towards this as well, but there is a break in the straight line at this point 2, 4. 2, 4 points and 2, 4 मा gap छ हेर, 2, 4 मा wall परेको छ लाइनमा, or there is a break, there is a hole in the line है. यसमा यो 2, 4 points and 2, 4 point मा यो break छ, there is a hole in the graph of the function. So it is the graph of the function f of x is equal to x square minus 4 by x minus 2. Okay. Okay. Your message ma unwanted कुराहरु पनि छ है. Okay. यसमा हेर त, यसको ग्राफ हेऱ्यो भने इट्स ग्राफ इज अ straight line having a break or hole at this point 2, 4. कसले टेन्स टु भनेर अलिअलि यो लिमिटको कन्सेप्ट बुझिरहेछ है। टेन्स टु भएको बेलामा हुन्छ भनेर लेखेको छ नि, टेन्स टु भएको बेलामा ग्राफमा हुँदैन है। टेन्स टु भनेको भ्यालु एक्जिस्ट भेरी नियरली इक्वल टु द्याट भनेको हो है। टेन्स टु भनेको एक्ज्याक्ट भ्यालु होइन, द्याट इज नट द भ्यालु एट दिस पोइन्ट है। अब त्यसको कन्सेप्ट अलि राम्रोसँग बुझ्नु पर्यो है। टेन्स टु भनेको अलिकति बुझेर मात्रै भएन है। टेन्स टुको कन्सेप्ट राम्रोसँग बुझ्यो भने नि बल्ल थाहा हुन्छ। ओके, अब यसमा यो ग्राफ छ नि, यो ग्राफमा होल देखिया छ। यु क्यान सी द होल इन द ग्राफ। इट इज द ग्राफ अफ दिस फंक्शन f of x is equal to x square minus 4 by x minus 2. Okay, now we come to the next. If the functions are not algebraic, the functions are transcendental. You have studied only the trigonometric functions which are not algebraic. So you can say the trigonometric functions are the transcendental functions. Okay, there are the functions which are not algebraic are the transcendental functions. And here you have studied only the trigonometric functions that are not algebraic and they are transcendental functions. There are other types of other functions which are also transcendental functions. Okay, transcendental functions. Okay, transcendental functions, the functions which are not algebraic are called transcendental functions. You have studied trigonometric functions. And the next, exponential functions, you are quite familiar with, but not using such functions. Your exponential functions. And the next, logarithmic functions we get. These are transcendental functions. Trigonometric functions, exponential functions, and logarithmic functions are the transcendental functions. The functions, these are not algebraic. For example, of trigonometric functions, you can take f of x is equal to sine x. It is a trigonometric function. F of x is equal to sine x is a trigonometric function. It is a transcendental function. F of x is equal to 2 to the power x. It is an exponential function. It is exponential term. The variable, the power is the variable in a function, so it is an exponential function. And the function, it is that is the inverse of the exponential function forms the logarithmic function, and the function in the form f of x is equal to like this log x. These type of functions are the logarithmic functions. This is the inverse of the exponential function. Exponential function, the inverse form of logarithmic function. These functions are the transcendental functions. F of x is equal to sine x, f of x is equal to the power x, f of x is equal to log x. These are transcendental functions, and particularly we can say that it is a trigonometric function. The function which is in the form of trigonometric ratios of unknown angles, that is known as a trigonometric function. So f of x is equal to sine x is a trigonometric function. The function in the form f of x is equal to e to the power x is known as an exponential function, and the function in the form f of x is equal to log x, or we can say ln x, these are the logarithmic functions, and these functions are the transcendental functions. Okay, now we come to the next. Smart functions my your introduction part, right? And we know that trigonometric functions are the periodic functions. It means their values repeat in the regular intervals. Regular interval values repeat so these functions are the periodic functions. Trigonometric functions are the periodic functions. Okay. Now we can define here periodicity of a function. Period of a function. The smallest positive number the smallest positive number, let us say p, is said to be the period of the function, period of the function f of x. The smallest positive number p is said to be the period of the function f of x if f of x plus p is equal to f of x. If f of x plus p is equal to f of x, for the smallest positive number p, then p is said to be period of the function. To find the period of the function, we check this condition: f of x plus p is equal to f of x. To find the period of f of x is equal to, let us say, sine x. As I told you before, the trigonometric functions are periodic functions, and we can find the periods of the trigonometric functions. The functions whose values repeat in the regular interval are called the periodic functions, and simply we can say that the trigonometric functions that we have studied are the periodic functions. And here that must satisfy the condition to get the period of the function f of x plus p is equal to f of x, where p is the smallest positive number. The least positive number or the smallest positive number p is said to be the period of the function f of x if f of x plus p is equal to f of x. Find the here we find the period of the function f of x is equal to sin x. Let me write the question. Find the period of the function, period of the function f of x is equal to sin x. To find the period of the function f of x is equal to sin x, we suppose the period is let for its solution. Let p be the period of the function f of x is equal to sin x. Period of the function f of x is equal to sin x. Then by the definition of the period of a function, we get p is the smallest positive number, so that f of x plus p is equal to f of x. Then we get f of x plus p is equal to f of x. F of x plus p is equal to f of x. This implies f of x is equal to sin x gives f of x plus p is equal to sin x plus p. F of x is equal to sin x, then f of x plus p is equal to sin x plus p. This is equal to f of x is sin x. Now we simplify this. To simplify this, you can bring this term plus sin x into the left side, becomes minus sin x, and you can use the formula for sin c minus sin b to simplify this, or simply you can use formula for sin a cos b plus cos a sin b in the left hand side and compare the coefficients to get the value of b, or simply एतिकै लेख्दै पनि हुन्छ है sin x plus b is equal to sin x cos b sin x cos b plus cos x sin b, sin x cos b plus cos x sin b, this is equal to sin x. Here we use formula for sin a plus b, okay? Sin x cos b plus cos x sin b, this is equal to sin x. Now we compare the coefficients of sin x on both sides. Sin x को coefficient right side मा कति छ हेर त 1 छ. यहाँ sin x को coefficient left side मा कति छ cos b छ. Okay, cos b is equal to 1 use गर्न पनि सक्छौ. Okay, or you can compare the coefficients of like terms भनेको यसमा cos x को coefficient हेर त left side मा cos x को coefficient कति छ sin b छ, right side मा cos x को coefficient कति छ 0 छ, sin b is equal to 0 गर्न पनि पायो. ए compare the coefficients है, sin x को coefficient compare गरे पनि हुन्छ both sides मा, cos x को coefficient compare गरे पनि हुन्छ. Comparing the coefficients of sin x गरे पनि हुन्छ, coefficients of cos x गरे पनि हुन्छ है. Okay, comparing the coefficients of cos x, sin x गरे पनि हुन्छ है. cos x we get, comparing the coefficients of cos x we get cos x coefficient left side मा sin p छ, cos x coefficient right side मा cos x नै छैन, cos x coefficient 0 छ, sin p is equal to 0. But p is a positive number, p smallest positive number of, this way sin को value 0 कति डिग्री मा आउँछ भनेर खोज्नु पर्यो. ओके, sin को value तिमीले खोज्दै जानु पर्यो. अथवा you can compare the coefficients of cos p हैन, त्यसमा cos x को coefficient compare गर्न पनि सक्छौ, sin x को coefficient हैन, cos x को coefficient compare गर्यो भने sin p is equal to 0 आयो. हामीले sin x को coefficient compare गरेको भए cos p is equal to कति आउँथ्यो, cos p is equal to कति आउँथ्यो, हामीले यहाँ cos x को ठाउँमा sin x को coefficient compare गरेको भए कति आउँथ्यो, cos p is equal to 0 आउँथ्यो. cos p is equal to 0 आउँथ्यो. cos p is equal to 0 आपछि 0 भनेको cos कति डिग्रीमा आउँछ रे, p is equal to 0, p is equal to 0 आउँछ हैन, cos p is equal to 0 आउने कन्डिसन खोज्नु पर्यो. Now from this you have to find the value of p that gives the period of the function. To find the period of every function, जुनसुकै फंक्शन को पिरियड निकाल्ने पनि यो हो यो. or you can go through this way, यहाँबाट यसरी जान पनि सक्छौ है. sin x plus p is equal to sin x छ नि, sin x plus p is equal to sin x छ भने sin x plus p is equal to sin x लाई sin x plus p minus sin x is equal to 0 गर्न सक्छौ. And then you can use the formulas for sin c minus sin d. Sin c minus sin d is equal to sin c minus sin d भयो भने 2 cos c plus d by 2 cos c plus d by 2 times sin c minus d by 2 x plus p minus x divided by 2. This is equal to 0. And this gives 2 cos p plus 2x by 2. This gives 2 cos p plus 2x by 2, p plus 2x by 2 times, here x and x cancel भयो, sin p by 2 is equal to 0. sin p by 2 is equal to 0 आउँछ. अब हामीले यो x भेरिएबल भएको नराखेर हामीले p निकाल्नु छ नि त हैन, then we take either or this is equal to 0 or this is equal to 0 भन्ने ठाउँमा हामीले sin p by 2 is equal to 0 लेख्ने. This implies sin p by 2 is equal to 0. This implies sin को भ्यालु 0 आउने भनेको त 180 डिग्री मा हो हैन, 0 मा आउँछ अनि फेरि 180 मा आउँछ. sin p by 2 is equal to sin 180 degree, that is sin 180 degree भनेको पाइ हुन्छ. P by 2 is equal to pi implies P is equal to 2 pi also. By this way, we find the periods of the trigonometric function. Simply we use the condition f of x is equal to f of x plus p is equal to f of x to find the period of the function. Okay, f of x plus p is equal to f of x. We use this condition to find the period of the function. And remember that p cannot be taken as zero. P like zero line upon a least positive number line by taking this condition f of x plus p is equal to f of x, you can find the period of the given trigonometric function. Okay, time is over now. Then we conclude the class today. Okay, thank you. Thank you so much.
Sir.
Thank you, sir.
Thank you very much.